So can you see a web browser?
Yes.
Okay. Let me see where is my chat window. So first of all, I want to ask you if you have any particular software that you want to discuss today. So you can write it in the chat or reply to me. Okay, I can see some reply in the chat. It's about Diamond and Kraken too. Mhm. Yes, so okay, so I will start with this section. Uh, so here I will discuss some good practices, yes, when you work in an HPC cluster like Kebnekaise. Um, some of them have been already discussed, but I put them here, yes, to emphasize their importance or the usability, yes. So first of all, so here there is a recommendation, use your project directory instead of the home directory, right? So it's common that when you just move to the cluster, you try to use the home directory right away because it is easier. So once you log in into the login node, then you get access to the home directory and it is easy to launch your scripts from there and then you start working, yes. But the problem is that this home directory has a limited storage space, which is only 25 gigabytes. And that's why when you apply for a project, yes, you, in addition to the computing uh, hours, you also get a storage space, which looks like this path, Pro, no backup, and then some name here. This is a default name. It has a structure of default name, but you can also suggest your custom name. And this has a much larger space. The default space is 500 gigabytes, which is larger than this home directory space. So it's highly recommended to move to this storage space, yes, as soon as you can. But some people prefer to work or like to work in the home directory, yes, because typing this long path uh, every time that one needs to change a file or move to a folder in this path, it's not easy, right? One needs to write this complete path, and sometimes one can forget uh, to 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 put the correct path. So one way to avoid this, yes, is by creating the so-called soft link, which essentially is a shortcut to this folder, right? So how you can do this? You move to the home directory with the cd home, yes, and then you type the command ln dash S, the name of the project, and here you choose a name, right? Some name that you want, and this will be a shortcut. So next time that you log into the login node, you will see a folder with this name in your home directory, which you can access as any other folder in Linux. It's just a shortcut. It's not a copy of this folder, it's just a shortcut of this folder, right? And you only need to do this once, right? Also, when you are working in an HPC cluster, right, it's a good practice to monitor the uses for resources. And we have a nice tool at HPC2N called job-usage, yes, which is available on the command line. So you just type job dash usage and the job ID. And this is the number that you saw with Birgitte that you obtain when you launch your batch script with the sbatch command. So after a couple of minutes that your program starts running, yes, you can type this job usage command, and then you will get a URL that you can then paste in your local browser, and you will get an interface like this one here, right? So it shows you the statistics of the program, yes, and how the resources are being used. And you only need to wait a couple of minutes, right? If your program is faster than that, and even a few seconds, you won't see any statistics here. So the program should be long enough and in general more like longer than a couple of minutes. So some statistics that you can see here is the CPU utilization, which is given in 100%, yes, metric. And also you can see the memory from the CPU side, the temporary directory, the Lustre usage. This is more from the Lustre system, file system. And here you can see the GPU utilization also in the 100% maximum. And here from the GPU side, one can also get the statistics for the memory utilization in percentage as well, right? And this is especially crucial, these statistics, right? In the case of the HPC clusters, because imagine that you request, right, uh, two nodes, two complete nodes, right, which in total should be 100%. But you forgot to load the correct module for running your program in parallel, or you forgot to put some flag from the software to specify the number of cores where the program should run. And at the end of the day, instead of using 100%, you will use 1%, right? And just a tiny amount of memory. So if the program only lasts a couple of minutes, yes, it's no problem, maybe, yes. But imagine that you set or allocated the time for 1 week, so all these resources will be wasted, yes. So pay attention to this type of analysis, yes, and here there is our tool that is available at HPC2. And other clusters in Sweden have could have something similar, right? Like in Chalmers, where they use a similar tool, and you get the URL automatically from your batch script once you submit it. but in Kebnekaise, we need to get it manually on the command line. So here also another good practice upon writing the support tickets. Yes. So the recommended manner to write a support ticket if you have problems with the software or the hardware, something is not working with your simulation, then the recommended way is to create a ticket on Super where there is an option to write a ticket to HPC2N local resources. Yes, but if you are in a hurry, yes, and you want to write to us right away, you can use this email address. Yes, but the recommended option is through Super because here you can specify some tags for the ticket, like if it is referred to bioinformatics or to any other field, right? So it's more complete, I would say. So some things to consider when you open a ticket. So describe the problem and the versions of the software that you are using. Yes. Also, this is very useful for us. You can provide us with a test case that we can copy just to try ourselves. And then you can give us the path that where we can grab that case, yes, so that we can reproduce the error or the problem that you are facing, and then we can give you uh, better, yes, better insight of what can be the problem. So if you already open a ticket, yes, use this ticket, yes, to discuss only the issue, yes, for that particular ticket. So it's difficult, yes, if you reuse the ticket to discuss a different issue, yes, and because the things get entangled easily, so it's better to separate the issues, one issue per ticket, yes, and yes, and if you have new issues, yes, you are free to open new tickets, right? No problem. So this is also very useful for us, right? So if you consider that the error that was discussed in the ticket is solved, please just drop us a line, single line, saying that the issue is closed, because otherwise we don't know if the issue was solved or if this was useful for you, and the ticket can stay in our queue for some time without knowing what happened with the issue. So just drop us a line. This would help us considerably. Okay, so these are some recommendations from my side. Yes. And you mentioned that you want to discuss about diamond. I prepared some examples here. I will discuss this here. So I created a documentation page, which I will paste on the chat. Yeah, for diamond. It's a basic at this point. So you have further information that you think that could help other users, yes, for this documentation. So let us know, and we may add this information on our documentation pages. So for some of this software, we have already experts, right? But there are plenty of software available, and for some of them, You will just know the basic besides of installing it on the machine. Yeah. So how to deal with Diamond? Diamond is installed as a module on Kebnekaise, and you have seen how to deal with modules with Vigite. So I can show you here how you can do this. So on the Kebnekaise terminal, you can type here ML spider and diamond. Yes, and you will see the different versions that are installed, right? So in my case, I will choose this one, which is the latest one that is installed. So then I can search for the dependencies before loading Diamond itself. Right? Module Spider and Diamond and the version. You see here that in order to download, to upload Diamond, we need to first load this tool chain. Yes, and I can also load Diamond after that. So then Diamond should be there on the terminal. If you type Diamond dash dash version, for instance, you will see that the version is already available on the terminal. So what Birgitte mentioned already that we shouldn't work directly on the terminal. And because of that, for long data production, yes, for longer than just 1 minute or 2 minutes, right? So we need to use a batch script. And here I will show you how a batch script looks. So this is what Birgitte mentioned previously. So I am using VIM as an editor, and this provides me with some additional features than other more basic editors like Nano, right? And some of them are not necessary at this point. For instance, the numbering of the lines, which is not part of the script itself, right? The script itself, it looks like this one is of the text. Let's start with the shebang, bin bash, which is the bash shell that we will use. Here we write the name of the project. And in this particular project, I will use this one, yes, for the course of today. I will specify one node, right? So that all the cores that I will choose are there only, right? They are not spread over several nodes, right? And here I specify the number of cores. These are the ones that will execute the simulation. So in this case, I will choose only one at this point, but we can change it according to the needs. For instance, if you have some heavy simulation, you can adapt it, right? Depending on how heavy it is. But for these simple cases, I will use one. So here I will do a purge module, yes, to remove all the modules from the environment, right? and here I will load the diamond, right, with the version that I want. So I took this example from the GitHub repository of Diamond, and they suggested you don't download a database, yes, with wget. So here you need to add dash dash no check, yes, uh, so that you don't need to check for the certificates, yes. So this part is not needed. Yes, there is a question.
Yes, I'm just wondering about this thing now that you're talking a bit about databases, because before this I used to work on Upmax, and there they used to maintain uh, databases for Diamond and Kraken too, because they are like so they were available on the server because the problem is especially with the Diamond databases that they are very big. So when you as a like personal user, when you try to like download them or get them into the server and then build your database, it usually like your your job is often cancelled because it just takes too much like memory and everything. So I was wondering if there is, because I tried to look but I couldn't find anything. So I was wondering if these sort of databases are available or maintained at Kebnekaise.
Uh, Not up to I know.
Okay.
Yes, there are some databases for other software, like for instance AlphaFold, because they are just too big. Yes,
Yeah.
but
I think yeah.
yes, but something that you could do, Birgitte. What do you think if the person can write a ticket and mention that the databases are large and they if they could be placed on Kebnekaise.
I could for sure like if like yeah, because I know other people like from my group and
Mhm.
so on. We use these databases quite frequently when we
Yeah,
do
yeah.
bioinformatics, so I could always put in a request to
Yes, yes,
yeah.
yes. This is my best suggestion at this point because Diamond is a software that I haven't heard about before or before this course, right? So maybe my colleagues are not aware of that, and there are, as you mentioned, other potential users that could benefit from these databases. And yes, I think it's worthy to write a ticket.
No, but
Mhm.
I will
Yeah.
do that for sure because
Okay, yes,
both
yes.
Diamond and Kraken too are very big when it comes to
Mhm.
like metagenomic work in bioinformatics and so on. So I will for sure put
Okay.
in a request for that. But thank you. I just wanted to check if you knew if it was available or not.
No, no, not for this particular software, as I mentioned it. Yeah.
Okay, thank you.
Yeah. Yes, yeah. You're welcome. And here you can see I am getting the database with wget. It's not that big in this case, right? And here is how I am running Diamond. This time is not needed, but I am using that to time how long this specific simulation will take, right? But in general, for data production, is not needed. Yeah? So then, for this particular case, yes, one is building the database, right? And here you can see one interesting option that I found, right? And it's not well documented in the repository. Well, I tried to search for it and I didn't find it. easily is how to specify the number of cores that you will use. Yes, and this is with the option -p. Yes, and here you specify the number of cores. Yes, for instance, in this case, in this particular case, I am using one core, and it is denoted with a dash C1, C lowercase 1. And in principle, I could use here also dash P1, right? But to make it more general, yes, and imagine that later on I change this value here to a different value like 8, right? So then if I forget to change here dash P8 as well, and I have the value of 1, right? So it will use one core instead of 8, yes? So, and we are in the case here that we will be underusing the resources. Otherwise, imagine that here I specify 20, yes, manually, yes, and here I specify only 8. So then in the job usage statistic, you will see a red line going beyond the 100, right? And a red line, this means that the resources are being overused, and also that the machine is heating up. Yes? So we need to pay attention to these things. So, but in the case or in the example that is cited in the repository, they don't use this dash P. And because of that, a daemon tries to use all the resources in the machine, and then you automatically get the red line. Yes. So you are over exceeding the resources. So instead of uh, writing here manually every time, yes, the number of cores that I specify in the Slurm here, I am using here an environment variable, yes, which gives me exactly this number that I specified here in dash C. So I will change it to 1 again. Yes. And this is a second case that is also mentioned in the repository. Yes. And here is for an example for clustering. Yeah. So here you can see here that I am using also the time command, but it's not necessary for data production. I can also show you one case, yes, where I run the simulation, but without this dash key, yeah, to see how the simulation behaves. So the time is 15 minutes because this simulation is very fast. I don't need to wait a long time. For realistic simulations, you may know better how long you can specify here, and you can specify up to 7 days, which means 168 hours maximum. Yeah. So, but the longer that you specify here for the allocation time, so the longer that your job would wait in the queue. So also try to get some uh, realistic value for the allocating time. Yes, and then I have the script ready, so I can submit it. with the sbatch command. So you see here the job ID. And here, after some minutes that the job is running, so it's running here. Yeah. After some minutes, I can take the URL with the job usage and the job ID. And then I can paste this URL, yes, in my local browser. And there I can see the statistics. But most likely you won't see any statistics in this case because the job was too fast, right? So you need to wait some time. But it's still running. But it needs some minutes. So what I will check now, the log files, you will see that two files are written, a job, the str.out with the output file, and this one for the error file. So you can open this one and see what the program is doing. So it's downloading the files here. And here it starts, yes. So I can also open the job.sh. So and remember that first I got the files. This is the first part, yes, when I downloading the file up to here. And then a daemon start running. And notice this one. If you remember, yes, here in daemon, I didn't specify the number of threads, yes, and because of that, the daemon uses the maximum number of CPUs that are available, which is 256. You see that this is a lot, right? And if the simulation takes a long time, you will see a red line in this site. But in the second case, when I run the daemon, yes, by using the same amount of CPUs with this environment variable, I see that I am using just one thread, right? So you can tune this value, right, just so that it matches uh, the size of your problem. And something similar occurs in the second case for clustering. So you can see here that I specify only a single thread. Otherwise, it will use the core resources in the node. I think it has a some script, right? So that it checks how many cores are in the node, and then it tries to use all these cores, yes, in an yes, egocentric manner, I would say. But so some programs they do this approach. If they see some resources in the system, they try to use all the resources. So that's why the job usage command is a nice tool. And yes, is there any question for this software? Okay, so you can read these instructions in our website. Yes. So regarding next flow, okay, so Kraken, um, let's see. Unfortunately, at this point, I don't have an example of Kraken, but let me see if we have some example in our documentation. No, we don't have an example, right? So I will check this and see how this works. We only have this basic documentation page in our website. So I don't have an example for Kraken. Sorry about this. So regarding the next flow, in the intro course page, I have, yes, and thank you for mentioning about these two software, Diamond and Kraken, because uh, uh, they were not common some months ago at HPC2, and this is my view. But now we have more users. And regarding Nextflow, in the intro course web page, there are some examples for Nextflow. Yeah? And here, this was an interaction with a user uh, from UPSC, and he provided me with some example for Arabidopsis. So you can see here how you can get the data, yes, for this particular simulation, which is more realistic. Yes. And here, let me see. What is, oh yes, okay. Okay. So this is the batch script that was used for this particular simulation. Oops, it has been moved. Next flow. Okay, the script should be here. I need to update some links. So this is a batch script from Nextflow. Yes. And the example is provided here, yes, in the intro course page. So you can see how the batch script looks like. Yeah. So again, this part is for specifying the project name. The project name, then I specify one node, and then here a 14 task. This was for writing the output and error files as before, and here is the simulation time. So in the case of Nextflow, so there have been some changes, yes, in the versions of the software. And because of that, we can always search for the software versions with ML Spider. and in this case, it's next flow. Yeah. So you can see here what are the different versions that are available. So, and in this case, this version is still present. Yes. So we can search for the dependencies in case that there are dependencies for this particular version, ML Spider, Nextflow. No, and it says that the module can be loaded directly, so we don't need to load any tool chain as we did in the case of Diamond, right? So it can be loaded directly. So these are some variables specific for this particular example. And in the case of Java, and here there's a way to specify the cache directory. And here there is a variable for the Nextflow home folder. Yeah? So you can specify what is the home folder. You can change this to your folder directory, to your project directory, sorry. And here there are the different options for Nextflow and for this particular example. So notice that in Nextflow, one can also specify the maximum number of CPUs. And there is an option here for the maximum number of CPUs. And I set it to 14. And here I requested some memory. But in our case, in Kebnekaise, so the memory is evenly distributed, yes, by the number of CPUs that you requested with respect to the total memory. So in this case, this will take 14 times the memory of a single core. So even if you specify here 1 terabyte or whatever you like, it will give you maximum, yes, the amount of 14, equivalent to 14 CPUs, because it's evenly distributed by the number of CPUs. Yes, and you can see here that the maximum number of CPUs is 14, and this is in agreement with the number of tasks that I requested here, 14. So also pay attention to these values, yes, and specify them consistently so that you don't specify more CPUs here than what you allocated in the bash script and the other way around. So there is also another way to run a Nextflow, yes, and you can see here that this is through a batch script. But the Nextflow has an option to submit jobs directly on the command line. So for this, so we need a configuration file, yes, that looks like this one. So you specify a profile contact name, some additional optional things, and also here the maximum memory, the maximum number of CPUs, and maximum allocation time, and some email address, and the singularity profile. So notice here that also you can specify any amount of memory that you want, yes, but on Kebnekaise you will get the proportional amount per node depending on the number of CPUs that you specify. And here is the file for Nextflow, which is very basic, right? So in this way, you can submit Nextflow from the command line as follows. You go to the project directory and then to your project, then create some file. You can also download these files that I mentioned here. Yes, with wget. And after that, so you load the Nextflow, and here on the command line, you can submit the script with the Nextflow, and then the input file for Nextflow, the configuration file, the input file, the input files that are needed for the simulation, the project, and here you specify the cluster options. So these are the options that you wrote in the batch script. If you remember, in the batch script, we have the number of nodes dash n1, the number of tasks dash n14, and the time, which can also be written as dash t, yes, and the time. So there are two ways to write the options. One with the dash, on a single dash, yes, and another with two dashes. So this is exactly what we have here, only one dash. But notice that here we don't have the equal sign, right? Because we are using the dash T option, yes? The single dash, and it doesn't require the equal sign. So the dash is 5 minutes. We are specifying in this case 28 cores and one single node. So when to use this option, the interactive one, when to use the other one as a batch script. So I would say that if the job will take a long time in the queue, the batch script is the recommended option, this one. Yeah. Because in that case, your job will stay in the queue and it will be running, yes? So you don't need to pay attention to the login session. So if that crashes, then your simulation can crash, right? So, but if your job is also very fast, or you are only testing your scripts, then a more interactive manner to work with Nextflow, it could be this one. I can see a question in the chat. Let me see. Is there a difference if I use Nextflow, which I installed in my home directory, and then calling Nextflow in my batch script instead of loading a module? Uh, well, if you install Nextflow and you get the Nextflow command and it is working, then there shouldn't be a problem. Yes, if you just pass the path, yes, of the executable in your batch script. However, on Kebnekaise, we don't recommend to work with self-installed versions that are already installed as modules. So for instance, if you need a later, a more recent version of Nextflow or other programs, instead of trying to install yourself, just write those tickets and we will look at the feasibility to install that the program as a module, right? So, so yes, self-installing software can be a bit tricky, right? And yes, it can create some conflicts to your paths. Yeah. However, also you are not restricted to this workflow, and if you install it already and it is working, so then there shouldn't be any problem. Something that could happen is that you install, for instance, Nextflow, self-install Nextflow, and then in the same script, you try to load another module or to use another software that you also self-install in another manner, and that can create a conflict. Yes, then it would be difficult for you to find out what is the problem. That's why we prefer to work in a cleaner manner and work with modules as far as we can. Yeah. Yes, but we can help you at any point if you have issues with your program. Just try it with your self-installed program. Let us know how it goes. And if you need a specific version of Nextflow, just write us a ticket. And you can see here that Nextflow is a well-used software on Kebnekaise because there have been several people asking for different versions of it over the years. Yes, and some of you also mentioned R. Do you want to hear something about R? Okay, yes. Uh, yes, I have in the introduction material. Let me write here. I have some examples for R. So, uh, so R is installed as a module on Kebnekaise. Yes, and there are different versions of R. We can search for that with ML Spider R. You can see here that there are some versions. Yeah. And notice that I am connected to the Kebnekaise theming session, uh, specific, specifically to the HPC, no, Kebnekaise dash TL dot hpc2n dot umu dot se server. Right? So, and the versions that I can see for some software, yes, on this login node can be different than those in the Kebnekaise dash AMD dash TL server. Yeah? So if uh, by some means you log into this server and then you search for R. So maybe you will see different versions of R or Diamond or Nextflow or AlphaFold or any other software. So the versions are not synchronized at this point, and I remember that Brigitte mentioned about this, and because of that, yes, yes, you will see different versions, and yes, you need to pay attention to where you are working with. Specifically, in this case, I am working in the standard Kebnekaise dash 11. Sorry, my microphone fell down. Okay. And here you can see the different versions of R. Yes. I can go to my material. So the first time that you try to access R, so you need to do some preparations. Yes, you go to this link here, preparations step, and you follow these instructions. Right? So read about this part. So R reads this file here, home.r environ, and it uses this file to read the environment variable, yes, and then this variable can be used when you try to install some additional packages in R. Yeah. So how you do this? You go to the home directory. Yes, you go to the home directory, cd home, and then you can create here a file called .r environment. Yeah. So I already did. So then after creating this file, so you uh, put some content to this file, yes, by echoing this line here. You pass this content to the R environment file, yes, and after that, if you open the R environment file, so you will see the content. So you see that this is the content in my case, right? So in your case, you will your the first letter in your username, and then your username, and there are packages, and this will uh, be used by R, yes, and it will replace this variable with the R version. Yes, and after that, once you do these preparations, then R will know where, yes, where to place the install packages. Uh, this is more specific, yes. So if you remember what I said about the limited space in the home folder, right? So notice here that we will be placing the installed packages in the home directory, which can easily saturate the 25 gigabytes. So a better approach can be to use your project folder, right? And to point the libs user variable to the project folder, right? So in my case, for instance, I have some versions of R here. You can see it here. And here the packages are placed. No? Once I install something, you can see here. Right? So, and it can create easily some overhead in the home folder. So then you can, instead of using the home directory, you can specify the project folder instead of the home, and everything will be placed in the project folder, which has a larger space. Okay, so once we do this, we can install packages and we can work with R. Yes. So how can we load R? So we already saw the different versions of R, and I can test one only. For instance, this one. First of all, I search for the dependencies, and here I need to load this tool chain before I can load R. So now R should be there, yeah? And I can test it. If I write on the command line R capital, so then I see that R is present, yeah? And the version that I loaded as a module. So then I can quit, and it suggests to save the image space. I will say no, because I am not saving that. I will return to my previous folder where I was before I moved to the home directory. So one can work with R, yes, on the command line, and we can do the basic stuff here, like using it as a calculator. Yes, but we already know that one can work uh, in a better way with R by using R Studio, and I will try this, and I hope that it works. It was working before the downtime in December, so I hope that it's there. So I will try RStudio on the terminal. Okay, so it's not there. Okay, no, RStudio is not here at this point. Interesting. So I didn't check this. I assume this was working. Let me see. MM Spider Studio. Okay. Now RStudio is not there yet, right? So it was there before the downtime in December. So one can write here RStudio on the terminal. Yes. and then the GUI was displayed, right? So now, if you want to work with RStudio, one way to do this is through Open on Demand with the RStudio session, as Birgitte mentioned during her lecture. So I will make a request of this RStudio on the command line. I found this recommendation in R, right? And this can be more advanced depending on uh, how is your current knowledge of R. So, but I found this interesting because this is somehow hidden, right, from R, and but it causes some problems in HPC center. So we saw previously that if we request more or less cores than we allocated in the R script, in the batch script, sorry. So this can lead to some underuse or overuse of the system, right? But this was from the CPU side. So in R and in other software, one can also underuse or overuse the memory that is allocated. So you can see here in the job usage plot that once we allocate the memory in the batch script, we get some amount, and we can also over exceed this value here, right? And in R, it's relatively easy to fall in this case. So I put here one example, yes, on how one can exceed the available memory per node. And here I'm using here a parallel uh, package in R, and PRIR is a package that is used for profiling the R code memory or and CPU wise. Yeah. So here I start with some value for the memory that is allocated in R. Yes, I haven't done anything except for loading the packages. So here there is a reference value, a baseline for the memory that was used. Yeah. And then here I define a relatively large data frame. It's not that large, but it's large enough to see the effects. So it contains only two entries, an ID and a value. This is the data frame that we will use. So here we use a function, yes, to process the database. And in particular, we do a modification to the I row, yes, one of the rows. And we return the value to the data frame. So, okay, so we do this, yes, and we report the memory that was consumed in serial mode. If you see here, this is serial mode because we haven't implemented any parallelization mechanism, and therefore this function will run on a single core. Yeah. But in R, there are several packages to parallelize the code, and in particular, one can use the MC-Lapply or MC-Lapply to process the data frame in parallel. So instead of waiting long time, yes, by using a single core, One can use 4 cores to to divide the total serial time in principle by 4, right? And make the simulation faster. So how it works, we use the MC-Laplace function, and then we iterate over the rows and also apply the process function, yes, and then use some number of cores. Here we need to specify the number of cores. And after this, we report the memory that was used with respect to the previous memory. Yes. And here, if you run this script, you will see that the memory was considerably uh, increased. Yes. And if you go beyond some values for the total memory in this initial data frame, so this memory will be increased, yes, in proportionally to the number of cores. So you can easily exceed the memory available per node. So that's why it's not easy to deal with this type of examples, right? And I have seen that this is common in R because up to this point, you may think, why is the memory increasing if the data frame is the same? Yes. So I haven't done anything explicitly to the data frame, and therefore the total space occupied by the data frame should be the same. But that's not true in R, yes, because in R, when we use some functions like MC-Laplace, so R replicates the initial data, yes, so that it doesn't get conflict with the different cores that are doing operations within this data frame. So it's a way of R to protect the data, yes, and to avoid the so-called race conditions on the data. But at the same time, it creates an additional overhead because it's doing replications of the same data. It's not a problem if the data is small, but it creates a problem if you are using many cores. Also, we can run a task directly on the nodes, yes, the login nodes, but this shouldn't be done, yes, because you will interfere with other users. So that's why we need to write the batch scripts. And this is one way. And now we have also the open on demand, where you can get access to the computing nodes. And there you can run your scripts, yes, as if you were, for instance, on a personal computer, and you run that directly on the command line. So here there are some instructions or some packages that we need to add, yes, to run these examples. And in particular, because we have already done the initialization step for the path to the libraries where R will install the packages, then we can install any other package compatible with the version, right? And here there are the possible packages that you can install so that you can run these test cases. So here I have a simple serial example. Somehow my path here was modified, yes, but you can find the example in the exercises folder. from the repository. And in the serial section, you can see the job.sh. Yes, this is one file, the batch file, and also is this. You can find the batch script itself, which is very simple. It just print out hello world, and then it takes some command arguments and print out the values of the argument one. Yeah. So how can I run this test case? I can go to serial in the exercises folder. Then I will take a look of this. No. I will do a purge. Yes. So notice that I have loaded another module, right? And because of that, if I try to open some editors or some programs on the command line, I will get a conflict, right? So I need to purge the environment so that all the modules that I loaded before are skipped or removed from the environment, and then I can use my editor. In this case is VIM. None of those I have this issue, but VIM has this issue. So this is the batch script. I will change here the project name, HPC2N. It will run for 3 minutes. Yes, I will request only one core or one task. Then I will use this constraint for skylate. And here there are the input and output files. I will specifically search for this version and see if it is present. No, it's not present. So I will take a different one. Let me see this one. So by the way, we had recently a major upgrade of the software, right? So most of the software that used to work are not working in the same way as it was before. I mean, loading the same modules. So we need to change the tool chain and also the versions of the software. So this is not common, but the upgrades were needed. Yes, on Kebnekaise. So that's why my scripts are not working after this upgrade in the late of December. So here I have loaded the R version and also the tool chain, right? And here there is a way to run R. You most likely have seen this, yes, in other centers, or maybe you're using this one. So here, this is one way, but there is another way to run that, and this is with R script. So I recommend to use R script because it includes some additional features, like for instance, reading command line arguments. For instance, here I have the batch script, no, the R script, serial.r, and I am passing one command line. So this cannot be done with the RCMD batch line. So what it works with the R script. I will test this script. If it is working, I will submit this job. And you see that I get the output and the error files, and this is the job ID. Seems to be running. And you see that it prints out a hello world and then the value of the argument. And this can be done with R script. Yeah? So that's why I recommend to use R script instead of this other way to run your scripts. Okay, this is a serial job. Yes. I have also an example of a parallel job. You can see here my batch script. Yeah, a project. And I will search for this version of R. So it seems to be present. No, no, it's another program. It's not R, it's NTRFS. No. Okay, so I will use instead the versions that I loaded for the serial case and remove these ones. Then I will check the content of cluster apply. So it uses the parallel library. So then it creates a list of numbers. Then we set the number of workers. In this case, I'm using just one worker. And here we run the simulation, yes, with cluster apply by using the number of workers. In this case, it's just one, right? And then we print out the simulation time. So we can also change the number of workers. Here, if we put, for instance, 2 workers, we also need to modify this number in our batch script and set it to 2. Yes, so they need to be changed in a consistent manner. So well, in this case, I will use just one worker. Okay? So then I will run this script. So it seems to be running. So, and you see that the elapsed time is 13 seconds. Yes. So I am using one single worker here. Yeah. So now I will change this value to 2. So, but here I will need to change the number of tasks to 2. And also I will open the cluster apply R script. And I also need to change this accordingly. Yeah. Then I submit the job. Then I will check the content. And you see that the time is, I will put this in a perspective. This output, and I will compare these two files. The one with a single core and the one with 2 cores. So you can see here the difference in the files. I was using here 1 core and these 2 cores. And you see the elapsed time is 13 seconds, and in this case is 8 seconds. So in principle, it should be exactly the half, yeah, but in practical terms, this idea value is almost never achieved, yeah. So, but at least the time decreased by a factor of almost 2. So depending on the size of the program, you can also request more workers, yes, and are already provides you with several packages that allow you to parallelize your code in a easy manner. Yes, so you don't need to modify your scripts considerably. Yes, this is for the parallel job, and I want to show you something about the job arrays, and this is something that Birgitte also covered. Yes. But in this particular case, it's just for R, specifically for R. So imagine that you have your script, this one, yes, and it uses some parameters. Like imagine that you want to simulate a system where the temperature changes, yes, according to some rule. Maybe one simulation will have a temperature of 10, the other one a temperature of 12, the other one a temperature of 14, and so on. It's changing in 2 degrees. And then this is the only parameter that you want to change. Or maybe you also have other parameters that you are changing. So job arrays are a good options in R. Yes. Here there is an example. So here I'm using the environment variables from R, like the job ID, also the task ID. So, and these variables can be used to tweak the temperature or any other parameter that you want. So here you get the Slurm variables. Use these job IDs, yes, in some way. And then here in the body of your simulations, you can use these variables to do your computations by changing the parameters. Okay, so this is the R script. And here is the batch job. Yeah. So again, we use the project ID, HPC2M. we request 12 minutes. In this case, we will use an array of 28 tasks, starting from 1 to 28. Here I am using a constraint which you may not need. So I am using this because at this point, this R version was only available on the Skylake nodes. But most likely you don't need that. And here I am writing the output files according to the job ID and the task ID. And I will copy here the same version that I use for the other examples, serial and job. So I will go here and grab this version because now this one is not present after the upgrade, the system upgrade. Right? And here I am running R with R script, yes, and the script that I wrote here for the job arrays. So let's see how it runs. So I can check in the queue, and you see now that there are many jobs running at the same time, yeah, and they are different because each simulation is using a parameter, yes, provided by the environment variable from Slurm. I can check also the files, yes, and you see the output and error files. Let's check two files, yes. I will check the file 10 and the file 11. And you see here, the job ID is the same, yes, but the task ID in this case was 10 and in this case was 11. So I can use these values to tweak the temperature gradient or any other parameter in my simulations. And these simulations, notice that they run all at the same time. Yes. Of course, I need to pay attention to the files that are written. So imagine that I compute in the same simulation something, some observable, and then I write all this data for the different simulations on the same file. Then I won't be able to use these results, right? So if you're writing or generating data for each simulation, then we need to store that simulation in a consistent manner, right? And we can also use the task ID and also a job ID and other Slurm variables, right? To tweak the external parameters. But this is an efficient manner to run plenty of jobs, yes, at the same time. And for job arrays, there is a very high limit for the number of jobs that can run at the same time, and it's about 10,000 jobs. So that's plenty, yes, in case you want to do many simulations. Yeah? So is there any questions about R at this point or any other questions?